New breath, I feel the grip releasing, scraping my guts off of the ceiling. I got that sunny bunny feeling. Making time, breaking ground, sailbound day to chocolate town. Making time, breaking ground, sailbound day to chocolate town. Making time, breaking ground, Greyhound bus to chocolate town.
Welcome and good morning. My name is Chris Burke. I'm Dr. Chris Burke, but you can just call me Burke. And this is a Computer Science 1 Honors, CSCE 155H. I'm broadcasting this. I'm live streaming this on YouTube as I do all lectures. The recording is available immediately afterwards. And so if you ever need to go back and review anything, or you miss a day due to illness or travel or something like that, you can always go back to it. I always make sure that the audio is working, but we're good now. All right. So just today we're going to do a quick course introduction, and then this week you're going to get set up on all the technology and all the tools that we'll be using in this course. First of all, are you in the right class? Yes, nobody just walks into this course. You have to be invited through the honors program, the School of Computing Honors Program, or at new student enrollment. But there are, this is a highly challenging and rigorous course in that we are going to be introducing 2 programming languages. We do the exact same exercises, the exact same topics as the main sections, but we're going to be doing 2 languages in parallel at the same time. That's why it's highly challenging and rigorous. I wouldn't say that there is twice as much work, but there is a significant amount of more work. Some other offerings would be 101, that's mainly for non-majors or a starting point for potential majors. 155A is the other companion course to this, and 155T is the data science companion course. All of them use Python, right? Don't worry, you'll get Python at some point. If you go to CS2, the honors, next semester, hopefully all of you will, then we cover Python in the first 3 weeks and you're good to go, right? Otherwise, the main section that I also teach is 155E, and that is just C. Again, we'll be doing C and Java in parallel. And then for non-majors, but for other engineering majors, we have MATLAB, which is 155N. It doesn't matter what you take. It doesn't matter how much prior experience you have. It's okay if you've got a lot of experience. It's okay if you have 0 experience. We're going to start from the basics, right? I'm your instructor. I will be for the next CS1 and tentatively CS2 next semester. And we also have about, I think, 16 learning assistants. All you have to do is check them out in Canvas. There is a pool of learning assistants for both of my courses. And so on your course, unfortunately, they didn't put in everybody, but you can see the ones that are specific to this course. There I am. Matt is your course leader, and then we've got 3 learning assistants, Aditya, Anton, and Emmanuel will be helping throughout labs, help sessions, and everything else like that. We will eventually have an hours grid here. You are free to go to any of those hours, including the LAs for the main section. They'll definitely be able to help you with C. They'll probably definitely be able to help you with Java, right? So those that's us, right? What is this course about? And I like quotes, so I'm going to quote 2 people, 2 sci-fi authors. Douglas Adams is the first one. If you really want to understand something, the best way to try to explain it to somebody else. That forces you to sort it out in your own mind, and that's really the essence of programming. By the time that you've sorted out a complicated idea into little steps that even a stupid machine can deal with, you've certainly learned about it about it yourself, right? So that's exactly what programming is, right? Programming is problem solving. It's not just programming a machine. right? Machines don't solve problem even in the age of ChatGPT. It's garbage, right? It's just going off of solutions that other humans have already created. Any future solutions will still have to be created by humans. What computers are good about are processing large amounts of data very quickly. Humans are not good at that, right? It'll take you a long time to solve a million summations or something like that. That's why we have computers, right? And then the second one, in my experience, you assert control over a computer. You show it who's boss by making it do something unique. That means programming it. If you devote a couple of hours to programming a new machine, you'll feel better about it afterwards. And I put that up there because that's what you all are. You are going to be masters of the machine, right? Just regular old consumers that are befuddled by even their phones today. They're not masters of their machines. The machines are masters of them, right? So become the masters of the machine by programming it and telling it exactly what you want to do, rather than it telling you what you can and cannot do, right? At its core, again, it's problem solving. It was what computer science is. Computers don't solve problems, you do, right? Computers only automate solutions. Moreover, it's a discipline that's becoming ancillary to all other disciplines. You'll see that even a marketing person is going to want a software development minor. Why? Because in the future, who knows when that future is, everybody's going to have to know about a little bit about programming, right? To at least put together 2 Excel files to do something. They're going to have to learn a little bit of macros, which is programming. And this was declared by Isaac Asimov over 50 years ago, asking about 10 years ago. 2014 will have a few routine jobs that cannot be done better than by some machine than by some human being. Mankind will therefore have to become largely a race of machine tenders. Schools will have to be oriented in that direction, et cetera, et cetera, et cetera. Now, we're still not there yet in 2024, 10 years later, 60 years later, but we're quickly approaching there, right? Once we've got reliable cars, you can say goodbye to maybe 10% of jobs, right? Once you've got reliable automation like that. So everybody will have to become machine tenders. And even the drivers of the future will have to become machine tenders, because they'll be in charge of 10 automated trucks in a row or something like that, a convoy of some sort. What is it about this specific class, though? Or what is this specific class? It's an introduction to computer science. It's not just a programming course. You will learn problem solving as you go along, how to take those problems and divide them up into smaller and smaller parts until the stupid machine can do that small little part, right? And the world is process. We computer scientists, data scientists, roboticists, software engineers, computer engineers, whatever you want to call yourself, right? We're all the same. The world, we do not have a monopoly on problem solving. Because the world is a process, right? Biology is a computational process. Physical processes are computational. You can model them, right, and predict what's going to happen next. Economic patterns are a computational process. Can't be predicted too well, but we're getting there. And then, of course, all aspects of engineering, right? So basically, you're on the path to becoming the master of everything if you can program, right? I can't tell you how many people in other disciplines that don't know how to program are knocking at our door, asking for people. No, we're doing our own thing, right? Or no, you're not paying enough, right? Or whatever, right? So the topics that we're going to cover are these are the official topics, but basically you're going to be learning a top-down problem solving, taking a problem, breaking it up into smaller and smaller parts. You'll be doing that with a high-level programming language, 2 of them in this case, C and Java. That involves abstraction, software development principles, modeling, processing, et cetera, right? Also at the end, design and analysis of algorithms, such as searching, sorting, and recursion, right? So those are the official topics. And we'll essentially follow that throughout the semester, that kind of schedule. If you want to see the full schedule, you just have to go to Canvas, which we'll look at in a second here. Everything is organized into modules, right? Roughly 1 per week, but of course, because of fall break, Thanksgiving, right? It's not necessary, and some topics are larger. It won't be exactly like that. In fact, we have 13 modules, but we have 15 weeks of actual class. Each module has a pre-prepared tutorial video for the C portions, not the Java portions. And one thing that's different, I'll point out right now about the honor section, is you do not have graded readings. We have an online book in the main section, which is called Books, where they have to read it every week, answer some questions, and then they get auto-graded on that. Because in my experience, the last 10 years of doing this course, honor students are more self-motivated, more self-disciplined. I took that out, right? I do have suggested readings, recommended readings out of my textbook, which is completely free and open, and you can use it or not, whatever. But that's one of the things that I took out of the honors course, because I'm giving you more responsibility. I'm giving you more control over how you approach this course. Lectures are Monday, Wednesday, Friday, exactly right here. And again, like I said, I live stream them. So if you can't come or don't want to come or whatever, you don't have to. But I highly recommend that you do, so that you can ask questions. I do monitor the YouTube chat over here for any online questions, but I'm not great about it because it doesn't just ding at me that something happened. So you feel free to ask questions, even if you're in here and you want to put the stream on your computer and ask questions if you don't want to raise your hand or something. Labs are on Tuesdays and hacks are on Thursdays. There are two of them, a C version and a Java version. We'll talk about these individually here in a second. Again, my lectures are coded in Markdown, or the Monday, Wednesday, Friday. I code them in Markdown. What's that going to look like? Well, when you're in lecture, you're going to see something like this, right? Here is me writing notes as we go along and adding things. For example, print F. I don't have like PowerPoints or anything like that. I mean, I do have a repository of them, but I don't use them. My name is Chris. Right, so you'll see me not typing very well sometimes or whatever, but I code them in Markdown. This is what the rendered Markdown looks like. At the end of the day or at the end of the week, I commit these to a GitHub repo, and you'll see them on the GitHub repo. Where can those be found? Well, let's go ahead and go over to the GitHub repo, and let's go to, I'll post this of course as well, but we've got notes going all the way back to fall 2019, but here's our semester, here's your course, and here are those notes, but they haven't been updated yet, right? So I will be checking these in and pushing them out as we go along. If I forget to, just ping me and let me know. All right, that's what it's going to look like. You should still take notes, right? Because many studies have said that just sitting there passively watching something is not necessarily enough, right? But if you're taking your own notes, you can type them up, you can write them down, whatever works for you, right? So I'm still going to highly recommend that you take notes. I'm not going to grade you on your notes or anything like that. They're your notes. So take it or leave it. Also, limit distractions. Again, numerous studies indicate that social media is detrimental to learning. It's detrimental to your health, mental health and well-being. Even the mere persistence of smartphones makes you dumber, right, et cetera, et cetera. So everybody has their computer out, and I'm not going to police that or anything like that, but take your own learning, take responsibility for your own learning is what I'm saying, right? Again, I have videos, about 60 videos, 9.5 hours of material. There's about 5 videos for each module, 9 minutes each, broken down into small chunks, digestible. Those are, I would recommend that you watch them before class. You can watch them after class as a supplemental or whatever. Again, I only have C versions for these, no Java versions. It presents a different perspective, different exercises, etc. And again, it serves as a review. Oftentimes when you get a question on our online forum, that question was answered in lecture. I'm going to post the video time index. There you go. I'm not going to write out an answer because I already did the work for it. Or I'm going to post one of these videos at a time index, and there's your answer, right? So they are a valuable resource. Campus Wire is our online forum. Let's go ahead and take a look at it. You all should have been invited already. Once you sign in, make sure that you're using your Huskers email is usually the one that's used. This is going to be your course here. I already have a welcome message of what you can and should be doing prior to class, or prior to this week, but now what you need to be doing this week. Each week I start out with a weekly post of what we're going to be doing that week, what's due that week, what you're going to be doing that week, etc. And I also do a retrospective at the end of the course. If you have a question, you can post it on this forum. You can post it identifying yourself. You can post it anonymously. You can post it privately so that only instructors, me, and all the learning assistants will see. Right? If you ask us a question over email, we're going to help you. But if it's a general question, right, we're going to say, that's an excellent question. I'm going to take that over to CampusWire so that everybody benefits from the answer. So that a week later, when somebody asks the same exact question, all I'm going to do is do a link back to the original answer. Right? You, as students, can answer other students' questions. The one thing that you can't do, or that you shouldn't do, you can and you're able to do, but you shouldn't be posting code solutions. You can post small snippets, or you can say, what was it called again? Printf or println or whatever, right? You can ask those kind of small questions there. Right? Otherwise, that is our online help forum. We also have help hours. Again, there are 13 plus learning assistants and over 30 weekly help hours. We don't have the grid up yet, but you can see it's all held in Avery 15, Monday, Wednesday, and Friday. Tuesdays, Thursdays are, of course, labs and hacks, so there are no help hours during those days. And none on the weekends. And I think only on Wednesday do they go after 5 p.m., so business hours, basically, 9 to 5. I also hold my help hours or office hours in Avery 15, so if you need me, I'll be there. Right? Labs are on Tuesdays. Attendance is required, and that is slashed out. Why? Again, you're taking responsibility for your learning in the honor sections. We will be taking attendance, but that's just for record-keeping purposes. In the main section, we grade on that. Though they are required to be there and to earn 15 points or 10 points or something like that. They can earn the policy in the main section, though, is that they can earn those back if they don't attend, if they can prove that they are competent with everything else by earning 75% or more. Right? I'm not going to do that. Right? Again, it's but the lab itself is graded. Right? It's 15 points based on completion. That translates to roughly 1% of your grade. There are 13 labs, so that translates to about 13% of your grade. They are due on the same day at midnight. So your lab section, I think, is at 2:30. Tuesdays, what is it? Tuesdays, Thursdays, 2:30? Okay. All right. Don't quote me on that, but definitely look up your own schedule. But I've got some nods. All right. And you're not required to complete it in that hour session or hour and 15-minute session. If you need to, you can go ahead and turn it in by midnight the same day. Most people, the vast majority, do get it done within the lab time. Right? It is peer programming, so we recommend that you work in pairs. If you're timid about finding a pair, the learning assistants are there to help you. If you want to complete it on your own, that's fine. If you want to complete it before the lab and just turn it in, whatever, it's all auto-graded anyway, that's fine too, right? But if you do team up with somebody, one of you should be the navigator, one of you should be the driver. The navigator is in charge of the handout and saying where we should go, what we should be doing. The driver is the one in charge of the keyboard. Most likely you're going to be both having a computer anyway and switching off those kind of roles. You're both responsible for communicating and solving the problem, right? It's not just the navigator tells the driver, now type H, now type D, now type whatever, right? Don't do that. You're supposed to be actively communicating with each other. You complete the code. I've eliminated all worksheets, so just the code. And only one of those needs to be graded. There's a C version and a Java version, but for you, only one. So if you choose C one week, choose Java the next week, whatever, we're only going to grade one, right? But you should complete both. Right? It's the same exact exercises, just in a different language, just so that you're learning those both, right? If you already have Java experience from high school, that's fine. You're going to get, but that's high school Java, right? You're going to get a little bit more rigorous treatment of Java, right? Hacks are on Thursday, and again, attendance is required for the main section, not for you. You may work in pairs, but no other collaboration. You may work alone if you want to still. However, both C and Java versions are required. This is not due at the midnight of the same day because they're a little bit more substantial. They're on Thursdays, and they're due on the following Monday, generally at midnight. Some of those are adjusted because of holidays or whatever, but it's generally due the next Monday at midnight. If you do choose to pair up, you do need to follow the instructions in the handout and go into people, hack pairs in the Canvas, and then join a team. In general, you only need to turn in one copy. With the we'll grade whoever comes first. So Burke and Zielinski, right? We're going to grade mine because B comes before Z, right? We can both turn them in, but Zelensky's is going to get wiped out in favor of mine. If I don't turn it in and Zelensky turns his in, then that's the one that's preferred. But again, if we both turn it in, it's only one that gets graded. Right? It's graded based on style, documentation, design, and correctness. There are full rubrics, not in Canvas, but in the handouts. And it's all automated. When you go through your first lab and your first hack this week, you'll be introduced to the writing, hand-in, and grading process. You hand it into CodePost, and once you hand it in, it says, test 1 passed, test 2 passed, test 3 failed, -5. Right? That's fine. You go back, you fix it, you hand it in again as many times as you want up until that Monday midnight due date. Right? The most recent one overwrites, so if you've got it perfect, don't bother handing anything else in unless you're fixing style and documentation. You also see that when we grade it, we will have line by line comments, or if we subtract 1 for bad style here, we'll tell you why we subtracted that one. So make sure that you're going back in and looking at that feedback as well. Right? Again, going through this week, or videos 1.1 and 1.2, we demonstrate all this. There's also some PDC module. PDC stands for Parallel and Distributed Computing. I've been involved with a study and work group with National Science Foundation now for a couple of years on attempts to introduce these topics early in the curriculum rather than later as like an elective. Parallel computing is the de facto computing nowadays. Right? 10 years ago, 15 years ago, everything had one processor. There's no such thing as one processor anymore. Even your phones, even lowly phones here, have a dual core or quad core or something like that. This one has, I think, 8 processors or 16 processors, and then with hyper-threading, you can get it up to 32 processes. Right? Even my garbage Windows over here is Core i5. I don't know how many cores it has, but it's an i5. I'm sure that it has at least 4. Right? The brand new server that we just got that you'll be doing some of these modules on was just upgraded to 128 cores. And then over in the Holland Computing Center, they've got entire clusters with hundreds and thousands of cores, GPU cores, and GPU cores themselves have thousands of cores, right? So you can do a lot of computing nowadays with multiple cores, but you have to know how to do it. You have to know how to program in parallel, at least understand the issues involved with parallel computing. Right? And finally, we do have, unfortunately, exams. 2 exams throughout the semester, and then there's 1 cumulative final. They only constitute about 25% of your grade. These are what are called executable exams. In other words, it's like everything else you'll be doing in this class. So you're not going to be filling out bubble sheets or anything like that. You're going to be coding. We give you starter code. You write your code. You hand it into CodePost. Oh, it failed. Okay, go back, fix your errors, hand it in again, as many times as you want. We give you a 24-hour window. Right? So I think week 5, that Friday, that's not the game Friday. It's the Friday after the game Friday. That is your first exam. We're not going to have class. Instead, at midnight on Friday morning, the exam will open. At midnight on Saturday morning, right, so 24 hours later, it'll close, right? So you will, if you want to be up at midnight, don't be up at midnight. I get up at 5, so I would probably be doing it at 5. All right, and I get up at 5 and I start doing it. Oh, it's designed for only an hour, like this course is. But I'll do the first part, and then I'll wait until after lunch, and I'll do the second part or whatever, right? You can have that entire 24-hour period to hand it in and redo it, right? This one, unfortunately, or fortunately, is supposed to be a test of your own ability, so no teaming up on this and no collaboration, right? More details on that later, okay? Again, the honors course is different. They're smaller class, obviously. There are 22 enrolled here. I think everybody's here. But the other sections have 85. 155A, I think, has 90. Those are the 2 largest ones, though. Everything else is smaller because the student population in those is smaller. The other difference is there's no required textbook. Those in the main section will be paying $60 for the Xi books just to make sure that they're on task. Both C and Java are covered, and then the hack attendance is not graded. And then there are 2 hacks each week due instead of 1 hack. So a C version and a Java version. They're the exact same problems that you solve. So you solve it in one language, it is super easy to port that over to another language. Not automated, but once you've solved the problem, once you've broken it down so that a stupid machine can understand it, it's just telling the machine a different order for that particular line. Right? So once you've solved the problem, it's pretty easy to do the second one. Again, collaboration is not mooching. Don't undermine your own learning experience by just letting your partner do everything if you choose partnerships. It's not doing everything for yourself. Don't undermine the learning experience of your partner, right? Collaboration is an equal effort, and it is a good and valuable skill to learn. It's one of those soft skills, right, where you need to have communication between each other. You need to be able to understand when, oh, this one person is mooching and I need to sever that relationship, or I'm mooching and so I need to, I'm not learning as much as I should be, so I'm going to step away from that situation. That kind of understanding and the communication and conflict resolution that goes along with it, that is a valuable skill to learn. But otherwise, if you have a good collaboration, it is awesome bouncing ideas off of each other. Later on, we'll talk about rubber duck debugging. I don't have a rubber duck on my computer anymore. Instead, it's a Shiba Inu. And I used to have a rubber duck, or just a duck symbol up here to remind people that the best way to debug is try to explain it to somebody else, right? And if somebody else is not in the room, then you explain it to a rubber duck sitting on top of your computer. Because the process of explaining it makes you 9 times out of 10, you'll realize, oh, this is why I screwed up. I didn't mean, that's what I've said, but that's not what I'm doing. Now I can go and fix the problem, right? But another person is even better, because the other person will be saying, what the hell are you talking about, right? That's not how you do that. And, oh, okay, that's right. And you can go back and forth on that, right? Second pair of eyes, different perspectives, right? There are multiple ways of solving the same problem. I want to do it this way. Well, my partner wants to do it this way. They're both valid, right? You can go back and forth on why you chose that one versus why you chose that way. And it gives you another perspective. Wow, I never thought of solving a problem like that. That's a great perspective to have, and vice versa. Okay? Branch out. Don't just collaborate with your friends or people that you make friends immediately, because you'll be, trust me, in your professional life, most times you won't want to be friends with your professional colleagues, right? You want to go home and divorce yourself from the workspace entirely, right? I do have a syllabus. Let's see, let's go ahead and go to it now. That's just going to be all of the policies. Most stuff in there I just covered, but let's go ahead and take a look at it. Make sure that you're going to the honors section here. It's linked directly in Canvas, by the way. And then there's the syllabus. I do have a couple more interesting quotes here. For example, the readings were the most underrated things ever. I never actually read them, but I wish I did. Thanks for providing them and leave the whole course available to us. A former student taking this exact same course, right? Enjoyed the videos. Did not really watch them until later. A different student taking this course. Realized it was a mistake now, right? So learn from former students if you're not going to learn from me, right? And then finally, Bjarne Strousup, the creator of C++. There are only 2 kinds of languages, the ones that people complain about and the ones that nobody uses. Everybody uses C, whether they know it or not, right? Those Pythoners in 155A, what do you think Python is written in? C. Java, folks, what do you think Java is written in? The Java virtual machine is written in. The compiler is written in. It's written in C, right? Everything is going to be written in C because it is the lingua franca, the universal language, right? Because it is fast, it is efficient, right? But with great power comes great responsibility, and you can shoot yourself in the foot really, really easy with C. Eric S. Raymond, be aware that you will not reach the skill level of a hacker. He's saying hacker in a good sense here, white hat hacker. Or even merely a programmer if you only know one language. You will need to learn and think about programming problems in a general way, independent of any one language. To be a real hacker, you need to have gotten to the point where you can learn a new language in days by relating what's in the manual to what you already know. This means that you should learn several different languages, and this is why I do this in the honors section. Right? Regardless, even if you were in the main section, you'd be learning a second language in your second course, a third language in your third course. And then from there, you'd be expected to pick up whatever you need on the way. In fact, you'd take 322 which covers 7 programming languages. Right? Just little bits of it, like programming language paradigms, I should say. And then finally, another previous student in this course, I came to this class able to code constantly using references and needing to double check my code and taking a lot of time. I left as a coding machine. Right? The rate at which I did the last homework was nothing. It was like a whole other person. Don't compare yourself to others. Right? If there's some Java guru in here that gets the Java stuff done in a matter of seconds or minutes or whatever, don't compare yourself to them. Right? And they might have had 4 years of Java, and before that they were programming in Lua in Roblox. And before that, they were doing a bunch of stuff in Minecraft Java or whatever, right? Don't compare yourself to that person, especially if you're starting out. Compare yourself to yourself, right? Look at yourself in 4 weeks versus the person that you were in week 1. Look at yourself in 8 weeks versus the person that you were in week 4, right? That's how you should measure your progress, not against other people, but against yourself, right? And eventually, everybody in here is going to become a coding machine, right? All right, so there's the course info. You need to have had Math 301, 301, 103 or equivalent. That's high school algebra, I think, isn't it? I'm not sure what that is anymore. But there's a post-requisite for this course. To go on to the next course, you need a grade of C or higher. That's never a problem in the honors section. Make sure that you're familiarizing yourself with university policies, resources, and services. For example, let's just go to that really quick. Academic integrity policy applies to everybody at this university. SSD, that's Services for Students with Disabilities. If you have a documented disability, you need to be going to SSD office to determine what the accommodation is. I can't do that, right? And don't violate your own privacy by approaching me about what those accommodations should be. I'm just going to be sending you to the SSD office. I've never had a problem with fulfilling those accommodations. We can work around anything, right? Mental health and well-being resources. You have the CAPS, counseling and psychological services. If you're feeling stressed out or whatever, you need some counseling services. They do offer free unlimited counseling sessions. So that's another resource. The final exam schedule, emergency procedures, diversity and inclusiveness, and the sexual misconduct policies and all that stuff. I'll let you read those. We've probably been familiarized in some other orientation already anyway. If we are canceled because of snow or something like that, I might be streaming from home because I stream, right? If otherwise, like on the game day, the 20th, we'll probably just cancel classes altogether there. I looked at StubHub and that's Colorado, right? Oh, no, that's Illinois. Okay. I didn't look at StubHub for that, but Colorado is at minimum $300. I'm not going to that. No way. But the UTEP was only 20. So I don't want to go to that. All right. So again, we do here are the honor sections differences that we already went over. The skills objectives that you should be able to have by the end of this course. We're recommending that you read chapter 1. That's our recommended, right? We recommend that you watch video 1.1 and 1.2. It is a complete walkthrough of Lab 1 and Hack 1 respectively. Now, of course, those are only the C versions, but the Java versions are going to be very, very similar. There's Lab 1 and Hack 1. There's the Java version, Lab 1, Hack 1. There's some suggested reading, right? 35 habits that make you write bad code. Programming is terrible, so learn to enjoy it. Right? Is programming hard to learn? Margaret Hamilton's, there's a little biography on Margaret Hamilton there. Some other resources here, a Git tutorial, etc. Then we go down to the basics. Right? We'll start on almost immediately here. Already no class because of Labor Day. No streaming either on holidays. I'm not going to stream on Thanksgiving. Right? I do stream throughout the last week, but that's with usually with advent of code, so as review and practice. But otherwise, everything is exactly the same here, set up exactly the same. The recommended reading, the recommended viewing, and then your graded activities over here. Here are those PDC surveys that I was alluding to earlier. They're just surveys. They're based on completion. So you do part A and part B. Those are due by Friday at midnight on September 13th. Right? Each one of these, you just have to go to the assignments to see what the actual due date is. For example, when it gets loaded finally, right? Everybody has 25 free starter points already. Why? So that it would come out to a whole number, right? But it also gets you started immediately. Everybody in here has 100%, right? There is no reason why anybody should not have 100% by the end of the course. Of course, that's not point here, point there, whatever. It is still possible to get 100%. Why? Because you can resubmit as many times as you want, right? You can take our feedback and improve on the next one if you had bad indentation or something like that. There's Lab 1, which is due at August 27th, tomorrow at midnight. Unfortunately, you can't do midnight, so it's like 1 second before midnight. There's Lab 2, that's due the day after Labor Day, September 3rd, because there is no class on Monday, et cetera, et cetera. Or sorry, no, that is the Tuesday. I was thinking about Lab 1. That's also due on Tuesday instead of Monday because of Labor Day, right? But there are all the due dates. There are the exams coming up eventually. Right? You can see the exam schedule here. If you go down to week 5 is our first one, so plan ahead. Week 5 is Fix-It week, an exam week. If in the first 4 weeks you screw something up, that's fine. We allow 1 resubmission. Right? Again, you can resubmit as many times as you want, but even at the due date, if you screw it up, we will let you fix it in that in this first week. Or one thing. There are 4 hacks times 2, so 8 hacks, and then 4 labs. One of those things can be resubmitted during that week if it's screwed up. Why? Because we do a review, and on Friday, that's our first exam, the 27th. Okay? Any questions so far? All right. Again, there's your points, 1,200. It adds up to, that's why it's 25 starter points. Yeah?
I do have a question about
Sure.
resubmitting. Does that mean you can resubmit it once, or
You can resubmit as many times as you want up to the due date,
Okay.
and then it locks you out.
But if you want to redo something, fix it up,
Then that's that one Fix-It week.
Okay.
Yeah. I mean,
can you submit it one time?
no, you can submit it 50 times.
Okay.
Yeah.
So just one assignment you get to redo it?
Yeah, it's just one in the 4th week, yeah, or the 5th week. Yeah.
So, the campus wire you sent out about 2 weeks ago, you
Uh-huh.
had like the suggested, if you want to do more of the lab 1.0 and the hack 1.0.
Mm-hmm.
Are those the same ones that are due, like if you completed those 2 weeks ago, a week ago? Whatever,
Yeah, as long as you handed it in as
Yeah.
code post, yeah.
So those are the same ones?
Yeah, those are the same ones. So you're a week ahead. Congratulations. PDC modules, again, those are going to be just, they are just surveys, the first survey and then the post surveys, but there is some activities to do in between that we want you to do. Labs, hacks, and exams. Note here that since I've got the schedule completely done, the 15th week policy does not apply. That's generally a protection against for students against a faculty member coming up with, oh, we're going to have this brand new project and I just told you about it after the 10th week, but it's due in the 15th week or something. It prevents something, surprises like that. No faculty really does it, but if somebody does do something like that, you can complain about it anonymously, right? And get it fixed hopefully. Otherwise, standard percent distribution at UNL, A+, pluses and minuses count. There is no difference between an A+ and an A. It's 4.0 regardless, but when you get down here, they do make a difference. It's like 3.77, 3.33 or something like that. If you have questions about grading or believe that points were deducted unfairly, try to speak to the grader first, right? They're identified in code post. They have little comments everywhere saying, Alex did this, or Chris, I also grade. Chris did this, right? Try to address it with your grader first, and if it can't be resolved, then come to me. Generally, no late work is accepted. That's why we have the Fix-It week, right? If you just are completely swamped in week 3 and you cannot do hack 3 at all, right? You did the C version, but you can't do the Java version because and you missed the deadline or whatever. Fine, that's what the Fix-It week is for. But we're not going to accept it as late. Okay. Academic integrity, again, for the labs and the hacks, work with pairs, right? We encourage that. But for the exams, that should be your own work. And working in pairs means working with a human pair, not with an artificial intelligence tool like ChatGPT or Copilot or whatever. You should not be using those tools. There is a tool built in This is going to be our development environment. I should have opened it before for C. And there is a little chat bot in there that will let you debug your own code, but it's been designed such that it never gives you code. If you asked for the code, it would never give it to you. Where is it? Somewhere in here. I forget where it is, but maybe I closed it out. It's still loading anyway. So we'll let that load, right? Just don't use ChatGPT is the lesson there. The best way to communicate is through CampusWire, right? Again, because if you ask a question, other people are probably likely to have that question, but we only need to answer it once, and then everybody gets the benefit of that, right? So if you have questions, go ahead and post them up to here. Again, if you want to be anonymous, you can be anonymous to everybody. You can be anonymous to just your classmates, but identify yourself for us. If you've got something really specific, like my code's not working on line 15, and you are anonymous, good luck, because we're not going to be able to know who the hell you are to answer your line 15, right? So choose that wisely, right? Otherwise, that's CampusWire. Or I guess we're going to go back to their syllabus. And the Learning Assistant program. Learning Assistants are all undergraduates, just like you, that took this course last year, or that took it 2 years ago, or something like that. And of course, you are welcome and encouraged to join the Learning Assistant program. They get paid, I think, $12 or $15 an hour for 7 to 10 hours a week, or something like that. They hold office help hours. They help you out in lab and hacks, etc. And then how to get help. Okay. Back to these. No late work is accepted, academic integrity, etc. We do use what's called MOS. That's the measure of software similarity. It is so accurate as to, ping two, no, these two people definitely wrote this together. This person just changed all their variable names from A to B or something like that. So it is really, really easy to catch, right? How to succeed in this course. Don't assume anything about yourself, right? We start with zero knowledge, and even if you have strictly greater than zero knowledge, you will still learn something. Because no matter what you learned in high school, Python or Java or whatever, you're going to learn stronger Java. You're going to learn stronger Python. I've not seen a high school curriculum yet with Python, for example, that does comprehensions correctly. Anybody have Python in their high school? Or did you do comprehensions? List comprehensions, maps, or dictionaries is what they call them. You probably use dictionaries, but not dictionary comprehensions, right? That's the Pythonic way of doing things. You never write a loop in Python if you can help it, right? Otherwise, coding is a skill that needs practice. You're not going to pick up a violin and expect to play decently on day one, right? Not even day 50, right? You need practice every day for the rest of your life. There's the 10,000 hour maxim, right? You have to put in 10,000 hours of practice in any one thing to become very, very good at it. I don't know if it's 10,000 hours for coding. Whatever it is in the semester, you'll definitely become competent by the end. And again, don't compare yourself to others. Compare yourself to yourself. The takeaway here is that you may struggle, right? Everybody will struggle, in fact, I can tell you at some point, right? Because even if you've started out at a high level here because you have that 4 years of Java, eventually you're going to hit that next tier, right, where you're going to struggle to get to the next one, right? However, the main takeaway here is that everybody can succeed. Okay. All right. So I just want to show this to you really quick. Right. Here's my demo. Here's basically a Hello World program. You saw me just click a button, log in. You're going to be doing that in your lab one. First of all, you need a GitHub account. Those are free. All right. If you sign up with your school address, you might get some freebies or something like that. None of them are worth it. So sign up for GitHub if you're not already. And then if you're signed into GitHub already, you'll be brought here. Right? This is a VS Code. That's a Visual Studio Code. But it's a Docker instance in your browser. This stuff stays here as long as you log in every 90 days or something. It is free, right? Because it's free to us because we're mooching off of Harvard. This is for their large CS50 course, but they don't know that you're not in CS50, right? So you can go ahead and use this. Right? It's got a nice little file explorer over here. It's got a code editor over here. You can open up multiple tabs. So there you go. Make sure that you're on the right tab though. And then it's got a command line interface down here, right? You'll learn some command line interface as you go along. For example, if I go into lecture, and then this is CSCE 155H, right? Type ls for listing everything. There's that demo right there. Right? Let's go ahead and compile it. All it does is prints out hello world. Right? GCC demo. No news is good news in the world of Linux, right? This is a Linux. In fact, uname. Come on. Can't type today. There. It is a Linux server. Who am I? I'm Ubuntu. It's an Ubuntu Linux instance, right? I can zoom in so you can see that a little bit better, right? Anyway, those are commands that you won't be using, but you will be using GCC all over the place. GCC is GNU's C compiler, right? That compiles the code into an executable called a.out. I can run that code now by using ./a.out, and it prints out hello world. Right? Again, you'll be going through this process in your first lab. What you can now do is you can now download this file and then eventually turn it into CodePost. I don't have I don't have student credentials for GradePost, just instructor, so I can't show you the hand-in process, but I do in the video. Right? But otherwise, there, all you do is make changes, right? Printf, print. My name is Chris. There's a problem there, right? You see it immediately? When I try to compile this again, oops, it should have been saved. That is, oh, sorry, I was editing the wrong one. There we go. Print, hello, 2, there we go. It's automatically saved. There we go. Now there's a problem, right? Print. It's not print. It is, like the first one, print F. The F stands for formatted, right? Once I make that correction, I can go ahead and try to recompile it. No news is good news. News is bad news, always, almost always, right? There's a warning that I have no idea what print is. Did you mean printf? Right? Kind of helpful. Not everything is going to be that straightforward and helpful from the compiler, though. Right? And I can run it again. Right? Hello world, and then hello 2. Why did it go to the next line here? What did I put up here to go to the next line? Is that a backslash or a slash? Backslash. Why? Because the person standing facing right, are they leaning back or are they leaning forward? And that's how you know the difference between those. Once you add that back in, of course, it's not going to work still because I didn't recompile it. But if I recompile it, oops, needs to go inside. There we go. Once I recompile it and rerun it, yay, now it does go to the next line. So in 2 minutes here, you probably saw me typing a lot of stuff and really, really quickly. Well, that's because I'm a touch typist. Hopefully you are a touch typist. If not, you will be eventually. But how is I getting, going lightning fast on so much stuff? You get used to it eventually. You don't have to type out demo.c. You can tab over and it'll autocomplete for you, right? Autocomplete has been there for like 40, 50 years, right? It's only, autocomplete from like web interfaces where you start typing and then suggestions go down there. Where did it come from? Command line stuff. Right? I meant to go ahead and run it again. Clear a.out. I didn't type anything. What did I do? I typed the up arrow key, which goes up in your history, up to a.out. Right? There's no down arrow key. You hear it donking because there's nothing in the future. How does it predict what you want, right? But you can go throughout your history here to every command that you've ever done, a.out, and I'm just highlighting there. Right? One common mistake is clicking something that you shouldn't click. My terminal's gone. That's all right. Where is it? Terminal, new terminal, restored. Okay. Close that, close that. I don't think you can close the Explorer, but if you could, then that would be bad. You'd have to restore it somehow. You can make it just look like whatever you want. And this is why if you're down in the labs or you're at home or something, this is why programmers, developers always have 2 or more screens, right? because they've got their dev environment over here, they've got their compiling environment over here, they've got 50 other things all over the place, and that's why we need so much screen real estate. Unfortunately, I'm left with just the overhead here. I'll show you the same thing to you in Java on Wednesday, and then we'll get started immediately on the basics. Right? And like I said, this recording will be available immediately after this, after I stop the